Cool. So we should be live now. Thanks for those who are joining or watching this. It is streamed, but we will make sure that the recording's available um, in the usual places. So I'm joined by Timo. He's going to do some awesome demonstration of NGINX and more specifically NGINX Unit. Looks like some really exciting things. I certainly am interested to see what it's all about. So I will let you take it away.
Perfect. Thanks, Sean. Yeah, Happy New Year. It's not, I think, not too late to wish anybody a Happy New Year. And yeah, it's cool to be here and give a little bit of an introduction about what NGINX Unit is. I would like to keep it as dynamic as possible. So if you have any questions, if you are like anything along the way you would like to know more about, let me know, and we could take it from there and talk about more about things that are you're interested in. I don't have any PowerPoint slides, so hopefully that's okay. I'll use mainly the website to explain what it is, and anything else will be a live demo on an Ubuntu box VM I have here. So pretty interactive. No slides. First of all, I would like to give a short introduction about what NGINX Unit is all about and what changed the last years, and a little bit of a history from where we come from, and why we have NGINX Unit. So mainly the people when I'm talking about NGINX at like a couple of conferences around the world, NGINX is in the web space at least is a very common term. So anybody knows NGINX and for what it can be used as a content cache and reverse proxy and web server. So that is all about NGINX, the web server, the open source web server we have around for a decade. But other than that, we have a couple of other projects alongside of the core NGINX that are also very exciting, but not super well known. And I will take this opportunity today to explain you one project in the more depth and maybe link to some other projects you might be interested in. And NGINX Unit is a new project we released back in 2017. It was initially founded by Igor Sosoyev, the main creator and brain behind NGINX, the open source web server and reverse proxy. And Unit was the answer, or still is about to be the answer on many questions the community has about NGINX or struggles and challenges we have with NGINX. It is not a replacement for NGINX itself. So we are not trying to replace the current NGINX project. It is a different project. It's a different code base. We are not sharing any code or any other like internals with NGINX itself. It is described as a universal web app server, and what that means is that we combine the power of the NGINX web server. So that means that you can share static files on disk, like images and CSS and JavaScript files, and do some proxying. But at the other side, we are implementing the application server runtime of, at the moment, 7 different languages inside of the NGINX Unit binary. That means that you can run your PHP code or Python code or Ruby code natively on modules installed in NGINX Unit. So that means, for example, a PHP application was deployed using an FPM, Fast Process Manager, and NGINX as a FCGI proxy, for example. That's a common setup on the internet. And with NGINX Unit, we can combine those two things in a single product. And what that means is that we install Unit and the PHP language module, and then basically we can do a very, very simple configuration. That's what we can see in the demo, to run the PHP code without even configure an FPM externally, or without doing the typical NGINX configuration on how to interact with the process manager of PHP. And this is the core idea of NGINX Unit, to combine the two worlds, like the application server world, that you can run your application code, and the web server, proxy server world in a single new project. That's basically the main idea behind NGINX Unit in a nutshell. And let me go in the control API section, because that's basically the main interesting part. Because
sorry, Tomo. Before you begin, I actually had a question.
Sure.
So one of the big things nowadays is things like containerization, especially things like Docker and Kube and that. So how do you see like NGINX? I don't see it as maybe a replacement, but it could be quite useful using within Docker and that, or
definitely. So NGINX Unit fits great in a container as well. And let me make a good example here why NGINX Unit can help to simplify your container setup. Just imagine you have an application that needs some PHP code or Python code for the main API logic on one side. The front end is built with React.js or Vue or Angular, something that can be compiled in a single page application. And maybe third, you have some special project or part of the project that uses some Node.js integration to do PDF generation or another task on the side. So that means we have basically three main components. One is the application server part for the Python application, like Flask, to run your API backend. The other one is the front end, like the web server you need to serve your static files and your React.js single page application. And last but not least, the Node.js PDF generation service. In an old Docker setup without NGINX Unit, the first problem we will face with that setup is that we have basically three processes we have to start up: the Python application server, the web server, and the Node.js runtime for the PDF generation. And there are a couple of projects around to deal with multi-process in a container, and it gets very strange and very confusing very soon if you try to do multi-process things sorry, in a container. Especially like who is managing to start the Python server, the Node.js server, and who's taking care of the runtime and and scaling, maybe even inside a container. And that's what Unit can definitely help with. Because let me jump on the command line real quick and just show you some process overview. Can't really type today. So that's basically the current Unit instance we have. So what you can see is we have main process, and I'll explain what that is in a minute. We have a controller router, and then we have here some application processes. So it's a PHP app or a Python application. It doesn't really matter. But what you can see here is that Unit takes care of your application processes. That means you can boil down your CMD line or your entry point in Docker to Unit, and Unit will start up, and the Unit main process will take care of your Node.js process, your PHP process, your web server, maybe your PHP, and maybe 5-6 other application processes in a single container. So that means that if you want to keep this pattern steady, that you would like to have a single process in a container, a single process in quotes, because unit spins up a couple of more processes inside the container. But from a Docker file point of view, it's still a single process you have to start. It's just unit and not something like supervisor configuration shenanigans to start 5, 6 different processes in a container. So number one. Number two, this whole idea of maybe having 2 or 3 different containers in a single pod on Kubernetes with an FPM for PHP as a sidecar and another web server inside of a container to do basically the service delivery for a single service. But because of the single process idea, you would like to have 5 or 6 different containers inside a single pod. That gets very messy pretty soon. And that's what Unit can help with, because we have one main process, and that process takes care of all the application processes, web server, proxies, static file shares, or anything you can think of. So it simplifies the stack to deploy your application, even inside of a container or Kubernetes.
Cool. Yeah, that sounds pretty cool. Because I've dealt with Docker containers where you try to start up multiple services and it's not fun, especially when you're starting to deal with things like Alpine.
Yeah,
It can
right.
be very problematic. So that's awesome.
Let me basically just bring up the Docker file real quick. Looks like I'm connected to some VPN or something. It's super slow today. So yeah, we are around on GitHub. So NGINX/unit. And then we can explore that inside of package. And in package, we have the Docker file. Let's use PHP 8.1 as an example. So right, so yeah, that is basically the main Docker file for PHP. That's our Docker entry point. I'm actually looking for something here. Right. So basically, let's spend some time on the Docker part. We have Docker images for the different languages we support, like Go and Java, Node, Perl, Python, PHP, Ruby. But it's not necessarily based on a single language. You can easily use any, what you mentioned, Alpine or any other Docker base image you want, install NGINX Unit, and then add any language you want on top of it. So you can easily have Java, Node, Python, and PHP alongside with Ruby in a single container if you want. That's definitely not an issue. That will work. And then you can run your applications in different versions, like PHP 8 and 7, in a single container. And as said, the NGINX Unit main process will take care of all the other application processes without juggling too much with okay, what should start up my processes. Right, and that's something you can find. Yeah, that's what the part I was looking for. That's the minimal one, and then we support a couple of the main entry point is the Docker entry point D directory, and inside of that Docker entry point D, we are looking for PEM files. That's an exciting thing I will talk about in a minute, because the certificate management for end-to-end TLS is very awesome in NGINX Unit. So we will look for PEM files, for certificate bundles to upload to the unit configuration. Next, we will look for any JSON file that can hold the unit configuration. And last but not least, we will execute a shell script inside of Docker entry point D to configure or do some like npm install task or whatever. So that means you're pretty open how to start up unit and what task you would like to apply before actually you start up the main server. Does it make sense for the Docker part?
Yeah. It'll be certainly interesting to give it a whirl and see it running in action, because but I can certainly see how it will help a lot. It just simplifies things. I mean, you could still technically do a lot of the stuff, but it's a lot more work, whereas this would greatly simplify it, make life so much easier. One configuration file, one process, all of that.
Right. Basically, let me jump in and talk about the configuration a little bit more. So then we can do a Docker example if we want. So the main benefit of the NGINX Unit configuration is that we have a RESTful configuration endpoint. It is not that, it doesn't sound very beneficial, but if we are talking about a Docker container, because the main enhancements in comparison with NGINX is that it's not a static configuration. It's a RESTful API that can be configured using a JSON payload or a JSON file. So that means we can change any single part of the application configuration or of the unit configuration independent of any other part. So it's not like what we know from NGINX, that we have a big configuration file and we send that file to NGINX and tell NGINX to reload the whole configuration, like everything we have. With Unit, we can configure any specific part of the application independent from another one using just a put request. Like an HTTP request to a specific config endpoint is all we need to configure Unit. In terms of a container, if we want to configure a Docker container, we can define a JSON file, like anything we need as a configuration, and simply ship it to the Docker entry point D directory. And that will pick up the configuration and will configure Unit automatically and will do all the rest. So that means what we can do is we can write a JSON file, we can create the JSON file in the CI/CD pipeline, use some other tools to configure it dynamically. And yeah, let me actually go inside of a configuration I have here, and let me explain what we have. That is a little bit, it looks a little bit messy because I've tested a lot of things before the stream based on some issues or problems we have currently on GitHub. But let me explain you the main concept. The main concept of our configuration is that we decouple the network stack, like layer 4 in the TCP stack, from the application stack in layer 7. And the glue and bread and butter in between layer 4 and 7 is our NGINX Unit router. And I will explain the router in a minute, but let's start with the network part. So what we have is we have a configuration object that's called listener. And the listener is basically the part that exposes some port or Unix socket to the outside world. That will receive your incoming traffic, your HTTP requests on port 8000, 8443. We can change that to something like, hey, just accept requests on port 8000 on localhost like 127.0.0.1, or and give an external IP address if you have multiple interfaces configured on your server. Not really the Docker use case. In Docker, I would say you configure it like star 8000, and that means that on any interface port 8000 we will listening for incoming requests. Same for 8443. And now what you can see here is the big benefit we have with the certificate management, because we can manage the TLS certificates independent from the application you are using. That said is, if for example, if you have tried to use end-to-end TLS with an Apache Tomcat on Spring Boot applications, for example, adding certificates to that stack is always a little bit painful, because you have to use a Java key store, or you have to import the certificates inside your project code. If you want to rotate the certificates, you have to change actually the application code, because the certificates are built in your application. Handling certificates with Node is different from PHP, is different from Python, from Ruby. And with NGINX Unit, it doesn't matter what application you're using. The certificate and the TLS handshakes are bound to the listener. It's not at the application level anymore. So you can simply configure your TLS settings on the listener, and that's it. So Unit will take care of the certificates and of the TLS handshakes and all that, and then we will hand over the request to the router, and the router will find the application, for example, or the static file share to serve JavaScript and CSS files as a web server, and then we pass an incoming request to the applications, and they are configured in the applications object. And the whole communication from the network stack on the listener to the router to the application is all via shared memory. So it's not a network connection. It's all shared memory. So that means as soon as the connection was TLS terminated and was received by Unit, we are not entering the network stack again. We are simply calling the applications in memory. So it's a real encrypted end-to-end TLS from your load balancer to the Unit application server if you want, which is pretty beneficial and very easy to use, because that is simply all we need. We define a listener, we tell the listener, hey, use TLS, and then we can define a single certificate, or that's another cool feature, we can define a set of certificates, and then Unit will use SNI to determine what's the best matching certificate based on the CNs or alternative names, and use that certificate to encrypt the connection. So that is basically the listener part. Would you like to go down to the routes and applications before we check the certificate management, John?
Yeah. I think if we
Okay. Right. So, and what we can see here is we have a pass object or attribute that tells Unit what to do with the incoming request. In this case, we pass it over to our routes object. And the routes object is an array based on an route object, and the route object that contains a match and an action. And this is a very powerful feature of NGINX Unit, and I like to call it a mini ingress controller, because what we can do here is we can match basically all the important HTTP metadata of an incoming request. We can check, okay, what's the source? Like, what is the source IP address or the source IP addresses? What is the URI? We can check host name. We can check HTTP headers and its values. We can check cookies, HTTP methods, request URI parts, anything you can think of can be matched here inside of the match block, which makes it very powerful to check, okay, what traffic or what request should be routed to what application, or maybe security-wise, what should be rejected. Like requests that do not have a specific cookie can easily be rejected in the unit router even before we send it to the application code. So that means we can make the HTTP router or the routing decisions that would normally be made inside of the application code part of the server itself. So you can like move this little piece out of your application code and let unit do this decisions of, okay, is this a legit request? Do we allow it? Do we not allow it? Do we block it? Or what should we do with that? Another cool thing is, for example, you can easily do A/B testing inside of a single container. For example, you define a cookie based on a customer login based on a given region, and then unit will check the cookie value, and all customers from United Kingdom, for example, will be sent to a new beta application that was designed for UK, and all of the other customers will be sent to the old application. So that is something that could be very complicated on Kubernetes, not technically speaking, but if you're an application developer and you would like to test something small and the ingress rules and definitions may be maintained by another team, that would require at least a request to your ingress team saying, hey, can you create another ingress resource based on this cookie value? Can you send this to another service, to another pod, to another deployment, whatever? And with Unit, the ingress team will send all the traffic to Unit, and then you can do the routing definitions in your own mini ingress, if you want to call it, and say, okay, if there is this cookie value, send it to that application instance and not to the other one. So that is basically the HTTP request router in Unit, and that I really love playing around with that, as you can see, because it's a really powerful thing. So yeah, that is the router, and what we can see here is I have played a little bit around and say, okay, anything that is PHP app star will be sent to the PHP app. Anything that is ISO star will be sent to app ISO. And the last block is anything that is matching the source localhost will be sent to the app log. And that is something important to know. The ordering in the router matters as it is an array. So if you would put this rule at the beginning, it will only use like the app ISO or the app here. In that case, that's what I mean. So make sure that you do this like, okay, if this does not match, do this, do this, do this, and have your fallback at the very end of the routes array. And then we come to the final applications part. And that's the real funny part, because as you can see, we define a set of applications and we have one app, that's the name, that's free to choose. You can use any name you want. And then we define a type. And that is, for example, a Python application. And that is a PHP application. They run on the same unit instance alongside. And then this is some cool stuff I would like to talk about. That's like isolation features, and I would like to show you a little demo here about this. Again, that can even be interesting in Docker, but that is more of a non-containerized use case, but I will explain that in a minute. So, and that's basically what you can see here is we have like 4 different applications on a single unit instance. Right, and for PHP, for example, we can define a user and a group that is the owner of the processes. And in this case, I have defined some isolation features. rootfs, that means that we will tell the application process. It's like an rootfs feature in a Docker container as well. So we are mounting our own directory structure in the application namespace and isolate it as much as possible. So that means if you have like and breach in your application code, remote code execution, or somebody was able to upload a web shell in a PHP application, if we define it with this rootfs feature and the isolation features here, the attacker would then only see the processes of this application, as well as the users and group and network namespaces and all that stuff that is kept isolated here. So even if we have an security vulnerability inside of the application and the attacker is able to control some remote code execution or a web shell, the attack surface is very limited because it's like a very, very tiny sandbox where we have this application code running in. So he cannot like pivot around the whole system, the whole VM, and check other names and other like directories and other application codes, or like play around with user home directories and do all that funny stuff you normally do when you are on a shared hosting server. And that's something I was playing a lot around with all the isolation features and the rootfs features, because I think that is one of the major things we should enable per default in the future. That will enable security by default. So that means if you run your application on Unit, and we're looking forward to make this configuration as seamless, as easy as possible. That means as soon as you install an application on Unit, it will automatically create this isolation sandbox that it is isolated per default. So no matter what your application is, like if you have some vulnerabilities in your application code, that's still a problem, but the amount of damage an attacker can do is limited to the isolation we have provided here. And that's my favorite. Next to the TLS support, that's one of my favorite things at the moment to work on, to make this isolation experience as seamless as possible. All right, yeah. But so these are the main config objects. We have listeners, we have routes, and we have the applications. And let me just give you a small example of the configuration API then. So I have the controller. Let me do. So the controller process is the main process that takes care of the configuration of Unit. So this one can be exposed to a domain, to a Unix socket, or to a TCP port, and in my case, it's port 9000. So we do a simple call request to localhost 9000/config. It will print out the current loaded config in a JSON format. And what we can do is we can now use like applications, and that will just give us the applications. And if we want to do some stuff at the PHP app, we can do PHP app. And if we want to know, okay, what are the isolation params we have defined, we access isolation. And that's basically, and this is a GET request, and it works the same for PUT requests. So we can manipulate any given value, so very specific, by just updating what we really need. And that will be updated by the Unit controller API without restarting the process. So it's in hot reload and hot reconfiguration, without downtimes, without like changing the processes. And that's a very, very strong benefit of NGINX Unit compared to NGINX. in terms of how the configuration can be applied. So I really like this for the configuration API. As said, maybe not 100% Docker use case or Kubernetes use case. It still can be beneficial to see like what are different configurations at the moment in the container. But this applies to an VM-based installation more than to a Docker one. Something I would like to explain, and that was based on the certificates we have just talked about, and that's definitely a Docker use case, is we have a special configuration section that is called certificates. And this is the place where NGINX Unit stores all our TLS certificates. And what you can see is that it's different to NGINX. We have the possibility and the opportunity to make the certificate information transparent and accessible with the configuration API. So that means we can query, do we have any validity problems on this instance? Okay, at what time we have to change given certificates. We can rotate the certificates pretty easy. We can upload them with the REST API. We can download them via the REST API and can query some information. Okay, like, okay, what are the alternative names? What is the issuer? For example, if you want to change the root CA and you're not aware of, okay, what certificates we are deployed with this given root CA, we can query the certificate endpoint and can find out the information about the CA we use to issue a given certificate. And that is very flexible and powerful, that we actually parse the certificates we upload to NGINX Unit and provide this set of information within the configuration API. Yeah, so, and as said, I'm using the certificate management quite a lot because it's so much easier than managing certificates manually and do this OpenSSL juggling to find out if it's expired and how long is it valid and all that stuff. Right, that's now pretty easy with Unit and the certificate endpoint. We do have a tutorial on the website how to do that with Let's Encrypt. I think, yeah, that's the certbot thing. Yeah, that's something I have created a couple of months ago. I think it was like in 1.23, so it's a decent time ago. How to do that certificate management with Let's Encrypt. At the moment, we do not have an ACME integration in the CLI. We do have since 1.29, since the last release from before Christmas, we do ship a CLI-like wrapper, and it's a shell script, a bash script. But we are planning to write a more powerful CLI for Unit within the next releases. So, and that will then include a full functional ACME client that will do all this configuration behind the scenes, so you don't have to do that. So it's simply tell Unit what domain you would like to secure with TLS, and it will grab the certificates from Let's Encrypt, for example, and will automatically upload them and reconfigure your router to match, or the listener to tell the router what certificate to use. And yeah, as said, that's the tutorial using the certbot integration. I think that's also a very common thing. And basically, these steps are right now manually, but I have a couple of shell scripts that use this deployment hooks of NGINX Unit to automatically deploy certificates and update certificates after they got renewed by certbot. Right. Yeah, that's basically the certbot integration at the moment. It's very very manually processed right now, but we are working on a more automated one to make it more seamless for the user to work with Let's Encrypt. All right. Any questions so far?
No, there's none in the chat. I was actually going to ask about Let's Encrypt, so it's good that you covered that off. Or the Acme, which is good. Yeah, that was really powerful because I know certificates like one thing that many development teams in that struggle on. So having that as automated, like two lines or 3 lines of configuration would be hugely powerful, especially expiring certificates as well. That's a constant theme. So that's awesome to see.
Right. Yeah. Okay. Yeah. That's exactly why we think we should spend more time on simplifying the certificate management, as it's one of the number one pain points for all the application owners and sysadmins and DevOps engineers around managing their certificate stacks efficiently. All right, and I have a small demo in place. So let's hop back to the configuration. I would like to show you some of the isolation features, basically, and so we do have anything that is ISO in the URI string, we send to the app ISO, and anything else we send to the normal application. So now let's have a look on what basically are the difference between app ISO and the application. It's pretty obvious. The app configuration is pretty simple. It's just telling unit, hey, that's a Python app, that's the module, user and group is root, and that is the path where to look for basically the Python module. That's basically all. Inside of the Python application, that is in right. So that's basically pretty simple. It's reading the processes using psutil and just print a very ugly list of the process names and the username, the owner of the process. Well, pretty hacky, but what we can see is that when we type like API, which does not match like ISO, we will see we get a list of like all the different processes running on that box. We get the systemd process. We can find some other stuff on my Ubuntu box here. We will actually able to find something related to unit as well, right? So we can see the unit process for all the applications basically we have on that instance. So I think yeah, this is a common thing when we have remote code execution on the server, and we can check for the processes. We can see like database processes are running, other application processes are running, and all that stuff. So the isolation we have added here is that we define the Python app, and now we do basically 2 things. First is the namespace isolation, and second is the rootfs. Rootfs will mount a separate or new file system to the application namespace. So that means in this case, we tell unit, hey, use the root of your file system in quotes as the getting started entry or the main entry point. And then on top of on top of the rootfs feature, unit will use some features, for example, the pid isolation to mount its own proc directory. So inside of temp A21, we will then see so yeah, that unit will basically mount some wrong permissions. I have changed that lately to test something, but what you can see is we mounted in USR folder, we mounted temp and proc. So that means unit will like basically isolate the parts the application need to run and operate. And in proc is basically on the instance the main content or the main directory where all the process information live. Like anything we see in the PS output is basically information that come from the proc directory. And by creating its own proc directory and just mounting the necessary processes that are required and used or created by unit for this specific application, will change this output from like a whole process overview on the system to something that just looks like this. So it will just show us, okay, we have 2 processes. That is basically the application process and its prototype. And when we change the number of processes right now, so for example, let's do this. We can change that to processes and then can define a number 4. Quite, and so reconfiguration done. So that, let's check what we have just done. What we changed is the app ISO. And what we see here is the old output was 1 prototype. That is basically a template for unit to launch more application processes if we need to scale up based on traffic. And that is the actual application process. And when we do the PS output once more, we will see that with that change to 4, unit created now 4 application processes instead of just 1. And when we check the isolation here, now we can see, okay, we have the 4 application processes plus the prototype process. And that's what isolation make it very powerful, because even if somebody get access to view some process information, it is just in this sandbox. It's not possible at the moment to escape and check a process is running outside of this proc namespace. Yeah, as I said, this is my number 1 feature at the moment, alongside with the TLS support, to play around with, and to create an architecture pattern with Unit to create secure applications per default that are hosted and deployed per default in an isolated sandbox. Yeah,
that's pretty cool. I mean, if you do that on top of Docker, you've got a pretty darn robust thing. And as well as imagine, like in that isolation, they wouldn't have access to most of the tools that you would have, like curl and telnet and those kinds of tools, which they then use to pivot. I mean, sure, they could probably maybe download some of them, but it's just another hurdle they have to go through.
Right. Yeah, good point. I've just let me tail something up, real quick, and show you something in the log, because I was playing around with PHP and the web shell, and as we saw, we have this. Let me see. It is PHP app, and that goes to PHP app, and PHP app. Right. So, and that is not using the rootfs, but the rootfs is required to like map the proc directory. But that's what exactly what you said. Let's change what we have to PHP app-iso in our JSON file, and apply the configuration once more, just here. And then I can show you something that is exactly what you're talking about. And at the moment, we are discussing if this is a bug or actually a feature. let me apply that. Go back here and call that PHP app, I believe. Right. So that is basically a server output of the server variable. And what we can see is that the document root is empty at the moment because we have this root fs enabled. So it's basically a slash. It's not this typical var whatever what we normally see. And I have just uploaded a simple web shell to that. And normally, when we do some pvd command or some ls command or anything that is now we see the output is empty, and if we check the log, and that's exactly what you just talked about, PHP is now telling me, hey, I cannot execute command ls because we did simply not map something that is in user star. So any USR, lib64, anything that is in user bin, any like this system-wide ls, curl, dubget, whatever, is simply not mounted to this rootfs. This is a bug on one side, I believe, because that means if you would like to shell exec something in your PHP code, because you just need it, like gzip or tar or whatever, that will simply not be there. But on the other side, it's what you just mentioned. You will not be able to use curl here or execute any other like command because it's simply not mounted to the file system. And I've just tested this like 30 minutes or an hour before the stream. So next step for me here is, what is the minimal approach to like mount maybe things you need in your code? Because I believe that some shell exec commands are very rare in PHP applications, hopefully. So that means what can be done to, let's say you have a backup application and you use gzip or you use tar gset or any other system command. My next goal is, what is the minimal configuration in Unit to allow tar gset, gzip, whatever in your PHP sandbox, but not curl, not dubget, not netcat, not what's needed for reverse shell, for example.
So basically have an allow list of commands that you would then allow
Correct.
them to run. Yeah,
Correct.
that's cool. I mean, generally avoid executing shell code directly from a web app would be my my recommendation. It's probably good libraries to do all sorts of things like this. Certainly in applications such as like Java and Python, there's loads of libraries that you could use instead of actually having to execute those commands.
And that is this rootfs feature is the thing we just talked about. And let me show you here using rootfs. For Python, for example, we do mount the sys path, and for Ruby we mount like the gem path and some other directories as well. And the thing I was talking about is that I would like to make a configuration that mount for PHP, for example, single binaries. Like if you know that you need curl or you need tar gset or gzip or whatever, mount it inside of the rootfs array and do not allow the whole wide system USR lib64 USR bin directory to your PHP application. As said, this is a long way to go still, but my vision here is, or our vision is, to create a sandbox secured per default environment for applications.
Yep, that's the way to go. That's awesome to hear. It sounds really powerful. Doing things by default just takes a lot of pain away from development teams, and it also just makes things secure. So it's definitely the way to go.
yeah, as I said, it's still a long way to go. But yeah, it's great that you think it's the way to go, and it's a good and right approach. It's at the moment, the configuration, even if it's JSON based, is still not as easy as I would like to have it. But as said, this is just the beginning, and there's still stuff to do. And the main goal for the next releases is to make this sandbox configuration a lot easier, so that these maybe isolation features and stuff is behind the CLI, behind another powerful tool that a user can simply deploy an application, and per default, without even enabling it, we will isolate the application. And we know what does cgroup mean, and we know what uname mean and rootfs mean, without having a user having a deep understanding as a user about what is a rootfs feature, for example. But yeah, this is something I would like to ask all the people out there. We need the feedback. We need users and the community to use it, to test it, to give it a try, and tell us what's good and what's not, and what is expected, and what should be enhanced. So yeah, as said, try it out, and let us know on GitHub any issue you have with that. And as I said, we are working actively to make it better and even more powerful.
Oh, cool. Thank you. Thanks for taking your time going over this. This really looks super powerful. I really love the direction it's going, secure by default. And I know you've mentioned there's a lot of configuration which you can aim to improve, but even from what I see, it's not that much. And I think most people would be able to deal with it. And things like the integration into Acme that's coming along, and that is going to be pretty significant in my opinion. That's how we get systems more secure. It's like baking those things in, making it easier, and then allows developers and the likes to focus on things that they're good at and want to do, is building apps, rather than a whole bunch of configuration.
Right.
Pulling
Correct.
that out. So this is awesome, and yeah, no, thank you for taking your time to go over this. Really interesting. Interested to see where it ends up.
Yeah, thanks for the invite, and it's a pleasure to be here. And I would like to give another short intro about the isolation, cgroup, and security features, maybe in a couple of months' time, after the summer. And let's see where we are in like 6 months, for example.
Good. Cool. All right. Well, thanks again, and thanks to everyone who's taken the time to watch either live or a recorded session. Highly recommend you give it a play. Maybe even start using it in your own organization and apps. And echoing Tomo, just give some feedback. I mean, I know from experience, feedback is really important. So having the feedback is very helpful. So if you can, just give a shout out on GitHub. Yeah. Any final thoughts or parting comments?
Not from my side. As said, I'm always happy to answer any question along the way and help people migrate applications and runtimes to Unit if needed. So we are on GitHub. Do not hesitate, open an issue. Happy to read through them and work with you, with the community.
So, okay. Thanks.
Thanks, Sean, for your time, and talk to you later then.